Today I'm excited to share with you a project that's been a labor of my love recently. It's something I've been working on to address a problem that affects many, including my own grandmother. Now, we've all seen one of these before, an Apple Watch. And when we put it on, it's usually something we don't really have to think about. It takes us a couple of seconds and boom, it's on our wrist. Now, this is the same thing that I thought until I decided to gift my grandmother an Apple Watch. What I forgot to remember was that a huge part of our population suffers from diseases such as arthritis, which make even slightly dexterous tasks near impossible for them to complete. One such person affected by arthritis is my grandmother, and much to my dismay, I realized that my gift was not able to be used by her because of her condition. In most cases, I usually wouldn't really mind it. But I really wanted my grandmother to have an Apple Watch or any other kind of fitness tracker because knowing what's going on with your health can be a really key indicator for your future, especially at an older age. So I set out to make something that would address this issue directly, a fitness tracker that can be easily used by the elderly. Now, making this tracker wasn't easy. It took several steps of trial and error and working with my friend, Savi, who helped me ultimately bring this project to life. Now, what I'm left with is a really rough first prototype, and here are the brains of my entire device, and I'll explain how it all works in a bit. This being my first independent engineering project, I didn't want to be overly ambitious and take on too many sensors or data points that I wouldn't be able to synthesize in one project. So I started off by a simple measurement that I think most people use when they first get a fitness tracker: step count.
In order for me to get started on my project, I needed to decide which sensor I would use. Starting on an online shopping website, I could see various options, but I couldn't land on one. That is until I found out about the ADXL345 sensor. Highly compatible with Arduino and having a high range of outputs, the ADXL345 was perfect for my purposes. On top of this, it's compatible with I2C, which is a two-wire serial communication protocol with various built-in commands. When beginning to prototype my design, I kept in mind some design considerations. Firstly, I decided to use an Arduino Nano, mostly because of its smaller size, but its functionality very similar to a normal-sized Arduino. I also chose to use a perf board instead of a breadboard due to how compact and thin it is. Keep in mind that the main goal with this project was to make something that would be able to be worn by my grandmother, so everything had to be small. Now you will see a clip of my first time connecting my code to the Arduino on this perf board. Okay, I just got done soldering my ADXL345 to my Arduino Nano. So as you can see, this is my serial output. When I changed with the orientation of my sensor, I changed the values. On the other side, you can see how I actually did this. This is my first time using a perf board. On the side, you can see I connected these together with solder. It's not the cleanest job ever, but it does what it needs to. I used a jumper wire here because I can't solder on top of another connection. Yeah, it works. Although there were a few roadblocks coming into this stage, I felt like overall the project was very successful so far, as I was actually able to get very effective sensor readings. In order to interpret the sensor values, however, I had to use some physics analysis. The data above has been collected from a Logger Pro video analysis. By plotting the frame rate against a given distance of pixels, I was able to extrapolate acceleration and velocity values. This yielded some pretty interesting graphs, and it revealed the periodic nature of our footsteps. This periodicity is what allowed me to use loops in this fashion to quickly and effectively measure the amount of steps traveled. Another feature that I decided I'd really like to add to make my pedometer unique was fall detection. The code senses an error when the periodicity of someone's footsteps are not met. Here's a clip of me and my friend Savi testing out the feature as soon as we fix it. As you can clearly see here, our foot detection is a bit wonky, but overall I think it's pretty successful, and in our other trial runs that we didn't get on camera, we were actually getting close to around 80 to 90% accuracy in the footsteps measured. I was very proud though of how often our fall detection worked. It worked every single time we tested it. Another thing I'd like to highlight is my use of the HC05, a Bluetooth module. I soldered it in series with 2 resistors to ensure that too much current didn't flow through it. This was done with the aim of making the pedometer user-friendly so that my grandmother could actually use it. With all the programming and wiring done, it was time for me to figure out how I would fit this all into one package. To do this, I used Fusion 360 to design an enclosure for my electronics. As you can probably already tell, a huge issue is how tall it is. However, this was a limiting factor for me because of how tall the HC05 Bluetooth module was. It had to be this big because otherwise it wouldn't fit in the box. After finishing my design, I decided to outsource my print from a local seller. I gave him specific infill densities that found a good match between strength and lightweight.
Now, while this project started as a personal endeavor to help my grandmother, it's really indulged my love for engineering, and I've really developed a passion to work on more projects like these on my own outside of the robotics competitions that I do in school. So I'm excited to think about more ideas on what I can do, and even working on my prototype, taking it from where it is now to a much more practical stage later on. So thank you for watching my video about my project, and I'm excited to learn more about engineering on my journey.